Part 4, prove by mathematical induction for our integers n greater equals to 1, right? Mathematical induction questions. Basically, well, almost 3 marks, right? So what I get is when it says n greater equal to, this means I'll start with 1, n equals to prove n equals to 1. What I get is a to 1 minus 1. That's my left-hand side. So which is equal to a1, right? My right-hand side will be equal to a2 times 1 minus 1 over a plus 1, a minus 1. So what I get is a squared minus 1 over a plus 1, a minus 1. And we know that a squared minus 1, we can split that into a minus 1, a plus 1. And crossing the rest out. See if I can get another color out over here. A minus 1 cross out, a plus 1 cross out, and all I am left with is my here equals to a, right? Therefore, left hand side equals to right hand side and is equal to a. Proved for n equals to 1, right? 2 now, we just assume n equals to k is true. Right, normal process, prove n equals to 1, assume n equals to k, and then prove n equals to k plus 1. So now what we have is a, and then plus a3, so plus a3, plus a5, and plus so on, plus a 2k minus 1. Yep, just to make sure. And it's equal to a 2k minus 1 over a plus 1 and a minus 1, right? This is what we assume. Now it's 3. Prove n equals to k plus 1 is true. Okay, so what I will be having is a plus a3 plus a5 plus dot 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 plus all the way to a 2k 2k plus 1 minus 1 be equal to a 2 k plus 1 minus 1 for a plus 1, a minus 1. Right, now simplifying, so what I should get is a plus a3 5 plus dot 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 plus a 2k plus 1 and equal to my a 2k plus 2 minus 1 over a plus 1, a minus 1. Now, noticing this is what we are proving, okay? So we'll be start from left-hand side. Left-hand side will be equal to a plus a3 plus a5 plus dot dot dot. And our last term was to 2k minus 1, so plus a 2k minus 1, minus 1, plus a 2k plus 1, right? Now, our first part is already, we assume that it is true, equals to the part we're given. So we are a 2k minus 1 over a plus 1, a minus 1, plus a 2k plus 1, right? We're replacing by n equals to k. Now make common denominator as well as expanding. So I get a 2k plus 1 minus a, and then making the common denominator, a plus 1, a minus 1. What I will get is a 2k plus 1 times by a plus 1, or a squared. We'll do a quick little trick over here. So a squared minus 1 straight away, right? expanding, I'll get a 2k plus 1 minus a plus a 2k plus 3, right, minus a 2k plus 1 over a plus 1, a minus 1. And I will be able to cross out 2k plus 1 and minus 2k plus 1. And I'll be left with a 2k plus 3 minus a over a plus 1 and a minus 1. So I get a, factorize your a out, I get a 2k plus 2 minus 1 over a plus 1, a minus 1, and essentially that is my right hand side, right? And now you can say something, therefore, true for n equals to k plus 1, and then therefore by mathematical induction, right? By mathematical induction, the statement is true. For all n greater or equals to 1, right?